All right. So in the previous sessions, we were looking at what were the methods of gathering data and the types of data that there were available, and also what sources you can get them from. And finally, we saw how we can present this data either using tables, or using a specific type of graph, whether it is a cumulative frequency graph or a bar chart or a histogram. All right. So these were ways of presenting data. Now we are going to be talking about analyzing, or some tools that are used to analyze data. All right. So before analyzing the data, first of all, we need to make sure that we understand what the type of analysis we want to do is. So the first thing we're going to start with is talking about the central tendencies of data. Central tendency of data. What does this mean? This basically means if you have a set of data, if you have a table or whatever, all right? So let's say we have a table with values in it, okay? So like 5, 10, 15, for example, and the frequencies here, all right? It doesn't matter. We're just trying to look at the middle part of this data, where the center of this data basically is, all right? And try to understand what the overall middle part, whether it is through the average, which is the mean, or the median of it is, or what the most reoccurring part is, which is the mode which we will be looking at right now. Okay, so the first thing we need to look at is the types of data we have before we move on. So we have three main ways of presenting data, okay, depending on the type of survey we did and depending on the way we have presented it. So the first one is it's going to be raw data. And this is usually just a simple one table. For example, let's say, I don't know, let's say height. All right. And like you were measuring heights and you got one to be 65.4, 37.2, 88.9, and so on and so forth. So it's just a single table with one value of data. This is known as raw data. All right. So there isn't any frequencies given um, or any ranges given. It's just simple, straightforward data. The next type is single value data. This basically means that you're going to have a table such as this, where you're going to have your data over here. Let's say, for example, age and the frequency of that data. And let's say, for example, we're talking about 10-year-olds, 20-year-olds, 30-year-olds, 40-year-olds, and we have specific frequencies, whatever they are, of each specific age. So this is basically what is meant by single value. Here we have just one value that represents the data. It is not a ranged data or not a grouped data also. All right, so we do not have any classes or any intervals. We just have one single point, one single specific age. So these people are all at age 10. All right, they're not like between a specific range. So the last type of data is grouped, or sometimes called class data. Okay, and what does this mean? This basically means that you have the same similar table, but the difference is now, if we are talking about the same example of age, and we're going to have the frequency, here we're going to have a range of data, for example, from 10 to 15, 15 to 25, 25 to 30, and then like 30 to 60, for example. For example, it doesn't matter what the class intervals are, but the idea is you have a range. So you're starting from a specific age up to another age, and then you have like frequency values as well, depending on that type. So this is what is meant by grouped or data or class data, as in you have a range, a lower limit and an upper limit, a lower boundary and an upper boundary. All right, so these are the three main types of data. When you want to calculate anything regarding these data, it is going to be a bit different for each one when it comes to the actual equations. So let us start with looking at raw data. Okay. So before even starting with raw data specifically, actually, let us talk about the central tendencies, what is meant by that. So we have three main measures for central tendencies, all right? So the measures of central tendency, meaning how close to the middle value it is in general. So the first thing we have is called the mean, which I'm pretty sure most of you already know, which is also known as the average value. Okay, this is the main one, the most easiest one, the most common one you could say, which is the mean value finding the average of something. So this is usually done by finding all the data. So you're going to be combining all the data, which we're going to look at later, and then dividing it by the number of data we have. The second one is the median, which is also known as the middle number. All right. So it is not exactly the same as the mean. It is the number that you can say is in the middle of the set. The location of it is somewhere near the middle, and we're going to look at examples of that as well. And then we have the mode, which is the most recurring data. بما معناه, it is the data type that is that is always going to be repeated and all of a lot, يعني repeated the most, you could say. So most recurring or repeated the most. يعني it has the highest frequency in some cases as well. All right. So that is what is meant by these three. And these three are all measures of central tendency, talking about the middle area or the middle range, but each one describing a specific parameter of the middle or the central tendency that you're looking for. So let's start with raw data. All right. So the first one is for raw data. If we want to look at the mean for raw data, all right, so an example would be is if you have, let's actually use an example from the worksheets. So let us take the very first example here. This, if you notice, is presented as raw data over here, right? So before we even talk about the mean, let's look at this question. If you notice here, the question says in a company's quarterly sales report, the number of units sold each month was recorded as follows. So we are given raw data. We are not given frequencies. We are not given repeated values or anything like that. We're just given data. So if we want to, for example, put this in a table, we could simply just draw one single table and call this the number of units sold. And the values are going to be 150, 200, 180, and 220. All right. So this is your values, or this is your raw data given in this way. So to find the mean, first things first, to find the mean. All right. So the mean, like I said, this is basically the average. This is going to be equal to the summation of all your data, x, over your n. What does this mean? X is basically your data value. All right. So in this case, it's these values. You are going to sum them all up, as in summation, meaning you're going to be adding. All right. This is what summation means. And your n value, this is the total number of data that you have, or data. Excuse me. All right. So the total number of data that we have. So in this case, we can count them. We have 1, 2, 3, 4. So we have a total of 4 data points. Okay. So if we want to plug it into this equation, the mean is going to be equal to, sometimes this is given as x bar, and sometimes you might see it as mu as well. All right. This is equal to, this is just representation. This is going to be equal to the sum of x. What does that mean? It means all the values of x that we have here. So if you notice, we have 150 plus 200 plus 180 plus 220 divided by the total number that we have, which is 4. Therefore, the mean is going to be equal to, put this very quickly in the calculator, plus 180 plus 220 divided by 4, we get 187.5. All right. So this is the average number of units sold. The average number of units sold is 187.5 units. Okay. This is what is meant by the mean, and this is how you would calculate it for raw data. What about the median? So this was the first part, part A, the mean, part B, the median. When it comes to raw data, the first thing you need to do is sort the values from lowest to highest. Okay, this is the first thing you will do when it comes to the median. So if we look at the median over here, these are the values that we have. If we want to resort them, it is going to be 150, 200, 180, 200, and 220. All right. So if we resorted it from the lowest value up to the highest value. So the median is basically the middle value between all of this. So if you notice, the middle value is going to be over here. All right. The equation you could say for this is going to be n plus 1 divided by 2. All right. So for example, here we have 1, 2, 3, 4. This is our n. We have 4 values. So it is going to be equal to, this is the median. It is equal to n plus 1 over 2, which is 4 plus 1 divided by 2. And if you notice here in this example, we are going to get a decimal point. This is 5 divided by 2, which is 2.5. All right. So we don't have an exact number of the middle point. What does this 2.5? This isn't the actual median. This is the term value. So this is the term. All right. The nth term, basically, or the 2.5th term. So if we're going from here, we're going to go 1, 2, and then we're going to go here 3, and this is our 4th term. All right. So we have 4 terms. So we need to go to our 2.5th term. In this case, when we are not getting a whole number, when we get a decimal point, we go to the number before 2.5, which is 2, and we go to the number that is after it, and then we take the average of these two numbers. All right. So this is what you do when you have a decimal point. You're going to go to the lower number and you're going to go to the higher number and you will take the average. Okay. So if we look at it from here, we know that this is our middle point, which technically, if we calculate it, we got 2.5. So we're going to look at our the value that we have at 2, and we're going to look at the value that we have at 3, which are 180 and 200. And to take the average of these two numbers, you simply just add them and divide by 2. And this will be your median value. So the median is going to be equal to 180 plus 200 over 2 is going to be 190. All right. So the value of the median is 190. This is just to find the term. All right. To find the location, you could say, of where the median is in a number. Obviously, here we only have 4 numbers. It's very easy to see where the middle number is. If we have an even set of numbers, as in here we have 4 numbers, you're going to have to take the average of the middle 2. If you have an odd number, it is going to automatically just put you at the odd numbers location. All right. So this is doing it through the equation form without having to write them all down and finding it. But you will always have to reorder them and make sure you have it from lowest to highest to be able to find it in this case. Okay. Now we have talked about the mean. We found that. We found our median. If you notice, our median is not equal to our mean. It's a slightly greater. Sometimes it might be even less. It depends on where the middle of these numbers kind of lays. So it's not the exact same thing. The last thing is part C, our mode. All right. Our mode is simply the most repeated. That's all it is. So if you look at these values, okay, usually it's preferred if you order them and keep them ordered from the beginning so you don't get confused. We need to look at the most repeated values. 150 is not repeated, 200 is not repeated, 180 is not repeated, and 220 is not repeated. So what does this mean? This simply means that there is no mode existing. All right. So we do not have a mode existing for this question because we do not have any repeated values. There's just one values from each one. So basically we have no mode for this question. And this is how you would find the mean, mode, and median for raw data. Let's do one more example for raw data, but I want to select values that are odd instead of even. 2, 2, 4, 6, 8, 2, 4, 6, 8. These are all even. All right, let's look at this question, for example. So if we look at this example over here now, it says the monthly salaries in dollars of the team of employees are as follows. Find the mean, median, and mode. All right, so these are the values that we have. Okay, 3,000, 3,500, 3,200, 3,500, 3,200. So first thing, mean, very simple. The equation of it is sigma of x over n. So our n value, we need to determine it. We have 1, 2, 3, 4, 5 total values. So this is our n. And our x values, we're going to have to add up everything that is presented in front of us. So it's 300 plus 3,000 plus 3,500 plus 3,200 plus 3,500 plus 3,200 divided by n, which is 5 that we have found earlier. So our mean, it's very easy to find, very straightforward. We just put this into the calculator. So 3,000 plus 3,500 plus 3,200 plus 3,500 plus 3,200 divided by 5 is going to give us 3,280. All right. So this, in this case, this is our average. All right. The average salary, the average monthly salary. So you can say this is in dollars. Okay. What about B? B is the median. So again, the median, the equation for it is finding the term that is n plus 1 divided by 2, which is equal to our n is 5, so it's 5 plus 1 divided by 2. Remember, this is just the location, all right? The term location. It is not the actual median value. So this is the term location. So the term location is 5 plus 1, which is 6 over 2. So it is the third value. If you notice here, it gave us straight up the third value. It didn't give us any decimal points. So we have our median directly without having to find the average. This will always be the case when n is an odd number. Okay. So when n is an odd number, you're always going to get a direct value. And if we look at here, the values, we have to reorder them. All right. So let's reorder them first. So we're going to have 3,000 first, then 3,200, 3,200, 3,500, 3,500. Okay, so this is our value ordered from least to largest to most, yani. And our third value is in the middle over here. So this is 1, 2, 3, 4, and 5. Our third value is this value, which is our median. So median is going to be equal to $3,200. This is our median value. If you notice, you can easily see it when you have a small amount of numbers. You can easily see where the middle number is going to be without having to apply this equation. But in case if you have a lot of values, like you have a lot of numbers, this way it will make it just a bit easier to find the middle value of it. All right. Last thing we need to find is our mode. So for the mode here, all right, we need to look at repeated values. So if I copy paste this one more time, what are the values that are being repeated? So 3,000 is not repeated, 3,500 is repeated twice, and 3,200 is repeated twice. So we are looking for the most repeated value. But in this case, we have more than one value that is repeated twice, the same amount. Since they are both repeated the same amount, that means they are both going to be our mode. So 3,200, comma, and $3,500. These are both our modes in this case. All right. So it's the most repeated. And if we have more than one that is repeated as many times and it's the most, In this case, as in these are twice repeated for both, they are both going to be our mode. Very simple, very straightforward, but this is in the case of raw data. So what is our second case? Our single value data. All right, single value data, meaning we're going to have a frequency involved as well. All right, so let me find a question so we can solve it using a question, which will make it easier. So let's look at this question right here. So for single value data, the following are the ratings given by 11 study skills teachers in a student's presentation. All right. So we know that we have a frequency, which is the number of teacher. This is our frequency. All right. And this is our data. So as you notice, there is a singular data table, singular values for the data part, the ratings. يعني بس عندكم رقم واحد ما عندكم range. All right. And we need to find the mean, median, and mode for all of this. So in this case, how are we going to be able to find the median and the mean and the median and the mode? So let's start step by step. All right. The mean, we're going to have this equation now, which is the summation of the frequency times x over the total frequency. The total frequency, you can think of it also as n, which is the total number of values you have. All right, but I usually like keeping it as frequency, as it is much better. It's much easier to understand, and you wouldn't have a hard time calculating it anyways. All right, because you can find it in the table, and I'll show you how. So this is how you find your mean. So now the summation, if you notice, it is going to be the frequency times the data value. So remember here, this is our table. All right. This is our table. Actually, let me put it down here. So this is the table that we have. So remember that this is our frequency, right? Our F. And this is our data, which is our X. All right. In this case, I usually recommend adding one more column, as it will make it a bit easier for you guys to find the value of F times X for each and every one. All right. The reason you do that is because you need to sum them at the end and find the total. All right. So then we're going to have to find the total value over here. Okay. So this is how you would extend your table. So F times X, meaning 6 times 2, which is equal to 12. Same thing here, 7 times 4, which is equal to 28. 8 times 4, which is equal to 32. And 9 times 1, which is equal to 9. And now you are going to add all of these values together. So it's 12 plus 28 plus 32 plus 9 is going to give us 81. All right. So this is the sum, the total. All right. This is basically our sigma fx. This is what it is. Our sigma fx. All right. This is what this value represents. Our sum, which is our sigma fx. Okay. And what else do we need to find? We need to find our n. Our n in the question was already given 11, or we can find it by finding sigma frequency by adding all of these values over here, which is 2 plus 4 plus 4 plus 1, which is going to be 11. All right, so as you can see, you can always find sigma f, even if it was not mentioned in the question. Here it's said by 11 study skill teachers, so we know it's 11. But either way, it doesn't matter. You can find it from the table itself. And now we can apply the mean equation, which is equal to sigma f times x over sigma f, which is sigma f times x is equal to 81. So it is 81 over sigma f, which is 11, which is going to give us the mean value of, or sometimes written as x bar as well, 81 divided by 11, which is 7.37. All right. This is our how to find our mean value. Now, What about the median? Again, the median, it is very simple. There are two types of methods you can apply so you can find your median when it comes to the ungrouped single value with a frequency distribution. Before doing that, let me just check. Yeah, all right. So this was our mean. We found it. Our B is median. Okay. So the best method I would recommend is by using your frequency table again and calculating your cumulative frequency over here. If you remember from last session, cumulative frequency basically means we are going to be adding everything to each other to reach our final frequency. So this is our cumulative frequency. All right. This is our frequency. This is our X value. So cumulative frequency, the starting point is equal to the same frequency. Then here you're just going to add 2 plus 4. So this 2 plus 4, which is equal to 6. Then 6 plus 4, which is equal to 10. And then 10 plus 1, which is equal to 11. Again, where did I get this? So the first value is the same value over here. Then we are going to be adding this value, the same 2 value from the cumulative frequency, to the value here, all right, which is this 4. Then again, the next value 6, which is here, we're going to be adding it to the next value, which is 4 over here, all right? Then again, the last value of 10, we are going to be adding it to the value of 1, which is over here. All right, this is how you find your cumulative frequency. And if you notice, the last value should be equal to the sum of all your frequencies, which makes sense because you're adding them. So now you have 2, 6, 10, and 11. All right. We will apply that same equation that we applied earlier for the median, the same exact equation to find where the location of the term is. So to find location, all right, this is the whole idea, all right, or the term. The median is equal to n plus 1 over 2 to find the term. So just make sure this is to find the term location. It isn't actual value. All right. So here we know that our n is 11 plus 1 over 2, which is equal to 12 over 2, which is equal to 6. Okay. So now we know it is going to be our sixth term. All right. So we know it is going to be our sixth term. So you're going to go here to this value, all right? And you will see where the sixth term is. So remember, this basically means from 0 to 2 is over here, all right? This is from 2 to 6. It's going to be over here. This is from 6 to 10, and this is from 10 to 11, all right? This is the order of your values. So yani value 1 and 2 is going to be here. Value 3, 4, and 5, all the way to 6 are going to be here. And then 7, 8, 9, 10 are going to be here. This is not 6 to 10. It is actually technically 7 to 10. Remember, it is not including. All right. So I should actually write this to be clear. It's actually like this. This is from 0 to 2. This is from 3 to 6. And this is from 7 to 10. And then this is from 11 to 11, because it is only one value. So it's only the 11th value, the 11th term. All right. This is where the term location is. So now that you know that you have the sixth term, this is the value that we want, the sixth term. We know the value is not going to be between 0 and 2. We know it's going to be here, between 3 and 6, because we have the third term, the fourth term, the fifth term, and our sixth term in this row. Therefore, our value, since we don't have any decimals, our value is going to be the rating over here of 7. So our median is going to be equal to 7. Okay. I'm going to show you the other method so that I just explain how it is 7 and what I mean here by the term numbers. All right. Since we only have 11 numbers, we can write them down in order. So we have our smallest number, which is 6, right? 6, 6. We have 2 of them, the frequency. So basically, you're writing it 2 times. And then we have 7, which we are going to write 4 times. So 7, 7, 7, 7. Same thing with 8, we have it 4 times. So 8, 8, 8, and 8. And lastly, we have 9, which we have 1 time. So we have 9. Using the same exact equation, all right, which is the nth term, we know that we need to find our sixth term. So this is 1, 2, 3, 4, 5. Sixth term is over here, all right? This is how we found the middle value. This is how we are applying it in the cumulative frequency. When you're finding cumulative, basically when you find 2 here, this basically means that this is your first and second term over here. This is what this 2 represents. All right, it's your 1 to 2 over here. And then from 3 to 6, it's all these values of 7. And then from 7 to 8, so if I keep going here, this is 7, 8, 9, 10. And this is our 11th value. All right, this is basically what this representation means here. So up to 10, so everything after 6 up to 10 is going to be your 8s. And then everything after 10, which is the only 11 number, is going to be our 9. This is what is meant by that. So you can either write them down this way, but if you have large frequencies, like let's say this was 50, 70, 200, it will be very, very difficult to find your median. Another important point, here it was already ordered from least to most, all right? So you have to make sure, if it wasn't, you will order these, order from least to most. All right. So for example, if the rating 7 was first and then 6 was at the bottom, you're going to have to flip them in the table and make sure that the order is matching. All right. For median, always remember you're going to have to be doing the order. Number 3, for the mode, this is the easiest one to find from a table. And I'll show you why right now. You don't need to do any orders. You don't need to add any columns or anything. The mode, remember, this just basically means the most repeated. So in other words, it's the highest frequency, all right? The highest frequency. So what is the highest frequency we have? We have 4 over here, and we have the 4 over here. So these are going to be our values for the mode, very simply. So 7 and 8. These are our 2 mode values because they're the highest repeated numbers or the highest frequency values, and they're both at 4. Is this clear? All right. Moving on to, all right, perfect. Moving on to our last set of data, or actually, let's do one more question similar to this. Yes, this one, where it's not ordered, so you guys can understand what you have to do when you're solving if it was not ordered. So again, you're given your table over here for this question. We need to find mean, median, mode. So the mean, we know the equation is sigma f times x over sigma f, which is your frequency, all right? So we're going to add an extra column over here, which we will call f times x. Excuse me. And we're going to do that for each and every row, all right? Keep in mind, this is our frequency, and this is our x. So we're going to do 500 times 4 in the first one. I'm just going to write it here for the first one. So it's 500 times 4, which is going to be equal to 2,000. All right. And the remaining ones, I'm just going to calculate them real quickly. So 300 times 3 is 900. 400. This is 900. All right. 400. 600 times 1 is 600. And 800 times 2 is 1,600. And remember, we need to find our total now. So in other words, sigma f for this row, for this column, I should say, is going to be, we just add all of these. So 4 plus 3 plus 2 plus 1 plus 2 is going to be 12. And sigma fx is going to be adding all of these together. So it's 2,000 plus 900 plus 400 plus 600 plus 1,600. All right, which is 5,500, like that. All right, so it's 5,500. Now we can just find our mean applying the equation sigma of x, which is 5,500 divided by 12, which is going to be 458.33, and this is your mean. Now, what about mode or median, actually? So if I copy paste this table down here again, now notice that our order is no longer from least to most. This is the most important thing when finding median. All right, we need to make sure that our order is correct. Okay, so if I want to reorder these things, let's do that. So we know that 200 is our lowest value. Okay, so 200 is our lowest value. It's going to be 200 over here. And then after that comes our 300, which is in its correct place. So let's cross out 200, 300, then 500. All right. 1 second, then 500. Then we can cross it out, then 600, then 800. All right, in this order. Okay, but make sure again we are going to be fixing the frequencies for them as well. All right, so previously for 200 we had 2 as the frequency, and then for the 300 we had 3, same as it is. So 2, 3, and then the frequency for the 500 was 4, and then at the bottom they're 1 and 2. Okay, so this is how you're going to be doing your order. And just to make it a bit more neater, we can, just 1 second. So we know the things that are changing is only our 200 and our 500. Everything else is the same. So we know that this is not changing. This is not changing. This is not changing. So we don't need to rewrite it again here. All right. The only things that are changing is our 500 and our 200. All right. So if I just lock this over here, lock this value over here, value over here, and the value over here. Okay, so now we know that the first thing we have 200, which was of a frequency of 2, and 500, which is of a frequency of 4. All right, so now this was our first step. Order from least to most. Okay, and now we have that from 200 all the way to 800. So now that we have done our order, we can apply the median equation, which is n plus 1 over 2 to find the term. So it's going to be our n we found earlier, which is sigma f is equal to n. Remember, this is equal to n as well. So it is 12 plus 1 divided by 2, which is equal to, in this case, 13 over 2. So we get 6.5. Remember, when we have a decimal point, that means we're going to have to look at two values and take the average. So we're going to have to look at the 6th term and the 7th term and then take the average of those both. So first, we're going to have to find our cumulative frequency. So let me make a bit of space over here. So the cumulative frequency for each one, cumulative, is going to be starting from 2. Then you're going to add 2 with 3, it's 5. Then 5 with 4 is 9. 9 plus 1 is 10. 10 plus 2 is 12. All right. So this is our cumulative frequency. Where does number 6 and number 7 lay? So we know it's not here. This is 2 all the way to 5. So this basically means this 2, it is from 0 to 2. Then here it is from 3 to 5. Then here it is from 6 to 9. And then here it is from 10. Sorry, 1 minute. Let me see what I did. 3 to 5, 6 to 9. Yep, 10 to 11. Wait, 1 second. Wait. I did something wrong. This is gonna be, again, let me repeat from the beginning. This is from 0 to 2. And then this is going to be from 3 to 5, which is 3 values. Then we're going to be from 6 to 9, which is 4 values. Then we're going to be from 10 to 10, because there is no other value here. It is just going to be from 10 to 10. because we're starting from 10 after 9 and we're ending at 10. Yep. And then 11 to 12 over here. All right. So this is how it's going to be, because at 10, we only have one frequency. Okay. So our sixth and seventh value is going to be laying between here, 6 to 9. And since both the values are going to be 500, okay, both our values is 500. So this is 500 and this value is 500. So if you take the average of the two same numbers, all right, so if we just do it, it's going to be 500 plus 500 over 2. It is going to be also equal to 500 because they're the same number. The average of the same numbers is going to be the same number as well. So the median is simply equal to 500. All right. So this is how you use your cumulative frequency to know where your number is at, where your number is in between of, and how to find your median. And then the last thing, which is the easiest part, is just the mode. Which is the most repeated. So we're looking at this very easily. We can see that 4 is the most repeated. So the value of that most repeated is going to be, so most repeated means highest frequency. All right. Remember, this is our data and this is our frequency. Okay. So our mode is equal to 500. And remember, this is going to be data, not the frequency itself. You're not going to put the answer as 4. Keep that in mind for all of them, for median, for average, the mean, and the mode. It is always a number, a value of data. It is not a value of frequency. All right. So if the value is in BD, that means all of these are, the unit of it is BD. All right, BD. And the average as well is in BD. Okay, it will share the same unit as your data point. Now let's move on to our last type of data, which is grouped data or class data. All right, it is almost the exact same thing. Grouped data, sorry, 1 second. So 3 grouped data or class intervals. All right. So basically you have a range. All right. This is what group data means there is a range of values. This is almost exactly the same equations as we did over here for the mode, for the median, for the, I mean, not the mode, for the average, which is the mean and the median. It's the exact same equations, but there's one extra step you just are going to have to add. And let's use an example so that it can be easy. Let's do this one actually, so that we can do both at the same time. So this is what I would expect a question might come like. I mean, it is multiple choice at the end, so they might separate them, but they're going to give you a set of data over here. All right. They're going to give you a set of data and they're going to tell you to fill the table. So if I just bring this table down here, this is our data and this is our table. Okay. So we need to fill out the frequency table over here. Notice that the class starts from 41, ends at 45. The next one starts from 46 and ends at 50. All right. So meaning that these are both inclusive of the numbers at the beginning and at the end, at the lower and upper limit. This is what is meant by grouped data, by the way. All right. This is grouped data, as in you have a range. So if we want to fill this out, let's fill out 41 to 45 first. So this is 1. 41 to 45, this is 2. 41 to 45, this is 3. 41 to 45, that's it. So the first one is 3. Second one, it is from 46 to 50. Remember, this is inclusive, 46 and 50 inclusive of both, because the previous one ends at 45. So this one starts from 46. So 46 over here, 47 over here, that's 2. 49 over here, that's 3, and 49 over here, that's 4. So we have 4 values. 51 to 55, so 51 is here inclusive, that's 1. 53, that's 2. 55, that's 3. And 52, that's 4. 51, that's 5. So we have 5 values over here. And then the last one is 57, 59, 56, 57, 58, and 59. We have a total of 6 values. So we have our frequencies, and notice they are already ordered from lowest to most, all right? So it's from 41 at the beginning, and it ends at 60, all right? So this is our minimum value, and this is our maximum value, okay? Now, when it comes to finding the mean, okay? To find the mean, so we have our table. To find the mean, this is our first thing, to find the mean, all right? Let me actually copy paste this table over here. And let me erase this real quick. Okay. So this is our table. Okay. I'll make it a bit bigger. This is our table. So to find the mean, I told you it was the exact same equation, right? So it is f x over sigma f. The only difference is now this x, I usually name it xm in this case for group data, because this is the midpoint of the class interval. All right? The midpoint meaning the middle of this value. So what you would do here is you're going to add 2 new columns. Give me a second. Let me just actually take it down so we have space. So we are going to be adding 2 new columns over here. So the first one you already know, the previous one we did, which is our frequency times x, but in this case I'm going to call it xm because this is our x data and this is our frequency. And here we are going to write our xm values, which is our midpoints. All right. And to do that, how do you find the midpoint? The equation for a midpoint. All right. So the midpoint equation is equal to, if you remember from last time, the lower limit plus the upper limit or the upper boundary over 2. So for example, in the first case here, in the red case, it is going to be 41 plus 45 divided by 2, which is going to give us 43. This is our first midpoint. All right? The same thing you're going to be doing for the remaining values. So for this one, it is going to be 46 plus 50 divided by 2, which is going to give us 48. So this is our second midpoint. The third midpoint over here, right? This is 51 plus 55 over 2. All right, the small number versus the big number, the range of it, basically, you're going to add them and divide by 2. And this is going to give us 53. And lastly, this interval over here, it's going to be 56 plus 60 divided by 2, which is going to give us 58. And now you have to multiply this value with the frequency. So it's going to be 3 times 43. Remember, you're multiplying with the midpoint, and you're going to get a value. Same thing here. It's going to be 4 times 48. Here it's going to be 5 times 53. And here it's going to be 6 times 58. And now we are going to have to find our total as well. So this was our midpoint equation. I'm just going to make it smaller and keep it up here. All right, so this was our midpoint equation. And keep in mind that we need to do one more final row for the total. So we have sigma frequency, which we need to find, which is 3 plus 4 plus 5 plus 6, which is 18. All right. And we need to find the total of this over here. So first it's 3 times 43, which is 129. 4 times 48, which is 192. 5 times 53, which is 265. And 6 times 58, which is 348. All right. So this, you're going to multiply it with the frequency. You're going to sum them all up. I mean, you're going to just add them all up after multiplication. So 348 plus 265 plus 192 plus 129. This is equal to 934. All right. So this is sigma fxm. Okay, is equal to 934. And remember, our mean is equal to sigma fxm over sigma f. Sometimes they'll just write it, or if they give you an equation or a formula sheet, they're going to write it as sigma fx by itself, just x. But when you guys see any class, just always keep in mind, in any case, that x means the midpoint. All right? So this is going to be equal to 934 over 18, which is going to be equal to 51.89, whatever the value of this class is. I don't remember the question. It's talking about sales, so this is in BD. And this is how you would find your mean for this question. All right? And that's the only thing you need to find. Mode and median, I did not see any questions about those in terms of grouped data. Let me just double check real quick if there is anything, because even in the notes I checked everywhere, you guys are not taking anything about median because it is a bit longer, so I don't want to go into it if it's not required. Yeah, it's only the mean. There is no median and mode. All right, so for group data, you're only going to need to find the mean. Okay, so only the mean. Any questions about mean, median, or mode in general before we take a break and start standard deviation and variance? All right. Let's take a short break. I don't want it to be too long. So let's say until 6:07. All right, back at, 5:07, sorry. Back at 5:07 p.m. Okay. It's already uploaded on YouTube, the same link as it was always. You can find the recordings all there. Now, you don't even need the link anymore. Yani you can just go to the thing because I made all the videos public, so you guys can have access to all the videos. Just go to PolyTeach on YouTube, and you're gonna have all of the access to all of the videos there. All right. It is good. I usually put them in the same playlist that I did for foundation. So just go to the statistics section, and you're gonna see it all there on the channel. If you have any questions, feel free to ask during this break. I will be around. All right, let's go on to standard deviation and variance. So here in this part, this is finding the central tendency as in the median and the middle values and the average and the mode. We were looking at basically the middle values in general. So now we want to look at how we can utilize the middle value that we are finding and what is the main point of finding these middle values and how we can apply them. All right. So at the beginning, we were measuring central tendency. Now we are going to measure variability. Variability meaning how much change is happening, how much change, or you can say how uh, far from the median, everything, or the mean, I should say, it is, right? So how far from the average value it is for the data. This is what variability basically means. This is what variance and standard deviation also mean. The idea is if you understand how to find your variance, you can find your standard deviation much easily, all right? Because the main thing you guys need to know is that standard deviation is always going to be equal to the square root of your variance, all right? This is what your standard deviation is, all right? Deviation meaning how much it's deviating from the actual mean value, okay? I remember we did this before the midterm. You saw how to do it for basic values, for basic non-raw data values as well. And we will do a quick revision on that first. So the same exact idea, the same exact concepts are going to be applied, but the difference here is we're going to do it for our three sets of data. So we have our first, which is our raw data. Okay, so when we have raw data, it is basically just single value, and we're going to be applying it to it. And then we're going to be looking at how to do that. But before even going into the raw data or even going into variance and standard deviation, there are some terms that you guys need to understand. So first thing, I'm pretty sure you all already know this. There is the range, which is equal to the maximum value minus the minimum value of data. All right. So this is the maximum value of data minus the minimum value of data. All right. Not the frequency, the data. So our X value basically. Okay. This is what our range is. The other thing you need to know about is something called quartiles. What is a quartile? So quartile from the word, all right, quartiles, basically means every quarter of the way, every quarter of the way. All right. So usually you will have three quartiles. You're going to have your first quartile, right? First quartile, which basically is equal to your Q1. That's how you usually name it. And this is going to be your fourth 1/4, which is 1/4 of the value that you are trying to find, which is your n plus 1th value. All right, this is the term basically. All right, your second quartile, we have already actually seen our second quartile. Our second quartile is basically our Q2, which is equal to our median, which is the middle of your set of data. So it's equal to 1/2, the halfway point. So a quarter and a quarter gives you half. So it's the halfway point of the n plus 1th term, right? So this is the term. This isn't the actual value. This is the term, the location of it, basically. All right. So this is just giving you the location, all right, or the term. And then you're going to find the value at that specific location. That's your actual quartile. The last one being our third quartile, meaning 3/4 of the data set. So this is going to be 3/4, the third quartile, or a quarter plus a quarter plus a quarter. So it is n plus 1th of the term. All right, this is the term. Again, remember, this is the term, not the actual value. And the last thing you guys need to know is there's something called the interquartile range. All right. And this basically is sometimes given as IQR. It is going to be your Q3 minus your Q1. All right, your third quartile. So your third quartile, your Q3, minus your Q1. Right? This is all that this interquartile range is. Very basic, very straightforward. You're going to apply it the same exact way we applied when finding median early on. So when you have a data set, if you want to find your quartile, you can do that very easily. Just the same idea as median, but instead of dividing by 2, you're going to be either dividing by 4 or you're going to be multiplying by 3 and then dividing by 4 for the Q3. And let's look at a quick example of that. So let's look at this example over here. So if you have a set of values given to you like this, it says calculate the range Q1, Q2, Q3, and the IQR. So the first thing you're going to do is you're going to order them. All right, that's the most important step. You're going to order them from lowest to highest. So we have our 7, then we have 8, then we have 10, then we have 12, then we have 13, 13, 14, and 15. All right, so this is our set. So the first step is always ordering it because it's similar to median. We're finding the same way as median. All right, so we find our n value. Our n value is just we're going to count them. So this is our first, our second, our third, fourth, fifth, sixth, seventh, and eighth value. So we have 8 values. So n is an even number. All right, so let's find the first thing, which is the range. Range is very simple. It's maximum minus the minimum. So 15, which is maximum, minus the minimum. All right, this is how you find your range. 15 minus 7, which is going to give you, oh, I forgot one more value. I just noticed. We have a 19 as well over here. All right, so this isn't 15, this is 19, which is our maximum value. And our n is not 8, it is 9, so it is odd. Right? And this is our 9th term. All right. So again, maximum minus minimum, 19 minus 7, which is simply 12. Right? 7, yes, 12. All right. So this is our range. The first part of the question, we found it, which is our range. Now let us find Q1. So what we need to find actually is our fourth quartile of the term, which is n plus 1. This is for the term. So it is n plus 1, which is 1 over 4 times 9 plus 1, which is 10 over 4, which is equal to 2.25, if I'm not mistaken. 10 divided by 4. Oh, it's equal to 2.5, sorry. All right. Now you notice we have a decimal point. So this means we are going to have to look at our second term and our third term. All right. So our 2 and our 3, because 2.5 is between 2 and 3. We go up here, we can find out that this is our second term. Let me highlight it actually. So this is our second term, and this is our third term. So 8 and 10. 8 plus 10 divided by 2. All right, because our second term is this, and our third term is this. This is how you find your actual Q1. You have to take the average when you have a decimal point. So 8 plus 10 over 2, this is going to give you 9. And that's how you find your first quartile. Second quartile, or just simply the median, so Q2 or median, is going to be equal to n plus 1 over 2. All right? This is the term. So this is going to be 12 plus 1 over 2, which is 13 over 2, which is equal to 6.5. All right? Again, this means that the value is between the 6th term and the 7th term, because 6.5 is between 6 and 7. So we're going to look at our 6th and 7th number. This is our 6th number, and this is our 7th number. All right? 12 plus 1. Why am I writing 12? It's not 12, it's 9. Sorry. It is 9. Our n value is 9. So it's 10 over 2, which is simply 5. It is simply 5. So this is going to be our actual term. So it's the fifth term. So simply we're going to go here and we're going to look at our middle term, the fifth term, which is this one, and this is our median. So median, which is also Q2, all right? The second quartile is the same as the median. It is equal to, was it 5? 13, sorry, not 5, all right? And then lastly, Q3, which is going to be 3 over 4 into n plus 1 over 2. Sorry, not over 2, just n plus 1. This is, again, remember our term. This is going to be 3 over 4 into 9 plus 1. So it is equal to 3 over 4 times 10, which is 30 over 4, 15 over 2, 7.5. Again, here, we're going to do the same exact thing. Since we got a decimal, this number is between 7 and 8. Right? So we're going to go look at our 7th and 8th term. So 14 and 15. We're going to take the average of 14 and 15 because our 7th term is 14 and our 8th term is 15. This is equal to Q3, which is 14.5. All right, very straightforward. Just apply this and follow. Last step is the interquartile range. Very easily, it is, let me keep this in black. So interquartile range is going to be equal to Q3 minus Q1, which was 9. All right, so it is equal to 14.5 minus 9. So your IQR is equal to 5.5. Tamam? This is pretty much it. In the case if you had a table, it's the same exact way that I did for median. If you remember, you're gonna have to order the years 3, 5, 6, 8, 12. It's already ordered. You're gonna have to find your cumulative frequency, and once you find your cumulative frequency, you just are gonna find the same exact way we did earlier for median. I don't want to waste too much time on that. It's the same thing, and you just apply to find your quartiles and all of that. All right. The one thing I just want to comment on, I'm just going to keep this on the notes. So if you have a range, all right, I'm not going to go through all the steps. You're going to find your cumulative frequency. So it's going to be 4. 4 plus 3, 7. 7 plus 2 is 9. 9 plus 2 is 11. And then you're going to find 11 plus 3, which is 14. All right. And then you're going to write your ranges. So this is the first one is from 0 to 4. Next one is from 5 to 7. Next one is from 8 to 9. Next one is from 10 to 11. And next one is from 12 to 14. All right. So this is what you're going to do. You're going to find your ranges of your terms. Remember, this is where your term location is. All right. Then you're going to apply the equations for Q1, Q2, Q3. What I wanted to comment on is the range. The range is simply the largest number you find here. This is your maximum, minus the smallest number you find here, which is your minimum. So the range is simply going to be 12 minus 3, which is 9. All right. This is how you would do it for this table. You're going to find your cumulative frequency and then the term location. If you want, you can write down all the values. So 3 is 4 times. So you'd write 3, 3, 3, 4 times. And then you're going to write 5, 5, 5, 3 times, and so on and so forth. And you can apply that method as well. It is also going to be correct. All right. So this is when it comes to quartiles in general. What about now if we want to talk about standard deviation and variance and standard deviation? So again, I'm going to be mostly talking about the variance because standard deviation, as I said earlier, all you need to know about standard deviation is it is going to be the square root of variance. All right. And usually this is given as sigma, and the variance is given as sigma squared. All right. This is how it's usually the a notation of it as you can see. All right. So if I want to explain it using this example, so this case, this is the case of raw data. All right. So when we are given raw data, in this case, we are given a very specific, 1 second, we are given a very specific set for the packages, for example. So we're given 5, 6, 4, 7, and 5. All right. This is what we are given. The equation here, it will vary depending on whether you are looking for your population or your sample variance. So this is the two most important things. So in this case, in this question, it is asking for population. All right. So for population variance, you're going to have a specific equation. For sample data variance, you're going to have a different equation. All right. So for the population, in this case, your variance equation is going to be, there are two different forms of this equation, okay? But I just want to, I'm only going to be using one of them because it is much faster to solve using that one. But I'm going to write both of them just so you guys know what it is. So the variance, or also known as sigma squared, is going to be sigma x minus mu over your n value. Again, this is for population. Okay. This is the form that you remember that we did from before. Sorry, this is also squared here. All right. So this is the form that you remember from before on how to do it. You're going to draw your table and do all of that. However, there is a faster and shorter table that you can do for the variance. The variance is also equal to sigma x squared divided by n minus sigma x over n all squared. All right, where x is our data. Remember, this is just our data, and the n is our total number in the case of raw data. All right, here up here, the mu is average. So if you notice in this equation, you don't have to actually calculate the average at all while finding it. So it will reduce the steps of how to do it. So how would you actually do it? So for me, I usually say, draw this in a table so that you can simplify it completely. So we have these values. I'm just going to copy paste them down here. So these are the values that we have. All right. So 5, 6, 4, 7, 5. All right. This is our x value. Okay. Then in this case, actually, in the table, all you're going to need to do is find your x squared value. So you're going to have to square the values that you find here. So it's going to be 5 squared, which is equal to 25, 6 squared, which is equal to 36, 4 squared, which is equal to 16, 7 squared, which is 49, and 5 squared, which is 25. All right. This is how you are going to draw it. I'm going to make this table a little bit smaller for the space. So this is how you're going to draw your table in the case of raw data. Then you're going to have to find your summation. So your summation. So summation of x for the first one is going to be equal to, you're going to add up all the values. So 5 plus 6 plus 4 plus 7 plus 5, which is 27. And then you're going to find your summation of x squared. And you're adding the values of the squared values that you did here, which is 25 plus 36 plus 16 plus 49 plus 25, which is 151. All right. And obviously our n value, this is 1, 2, 3, 4. We have 5 values in total. So our n is equal to 5. And now we can simply apply this equation for, the variance. And how are you going to apply that? Very easily. So if I just rewrite the equation down here, sigma squared is equal to, this is variance. Remember, when you're doing squared, that means you're talking about variance. All right. This is equal to sigma x squared over n minus, open brackets, sigma x over n, all of it squared. So now you can just plug in your values for sigma squared. So the first one is the summation of x squared, all right, which we found here. This is this value. So it is 151 divided by our n value, which is 5, minus brackets squared division. So the next value here is our sigma x, which we found here. This is our sigma x. So our sigma x is 27 divided by, again, our n value, which is 5. Put that all directly in the calculator and you will find your final answer. So it is going to be 151 over 5 minus 27 over 5 all squared, which is 1.04. All right, so this is our variance. This is how much variation there is between the results and our average value. All right. What about standard deviation? Very simply, the standard deviation is going to be equal to the square root of our variance, or in other words, sigma is going to be equal to the square root of sigma squared, which is equal to the square root of 1.04, right? So our sigma is equal to the square root, or our standard deviation is going to be the square root of that number, which is 1.01 or 1.012, all right? 1.02, sorry, all right? And that's how you would find your standard deviation when it comes to a raw data, and if it's asking for population. Okay. Let's look at the case where it is not asking for population. Let's see when it's asking for sample variance, for example, in this case. Remember, this is still in raw data. We're still talking about the raw data, all right? Obviously, you need to know that this is raw data by just looking at it. Since you know you don't have any frequencies, you just have a single value. You know that it's raw data. If you have a single value here with a frequency, that means it is single data. And if you have a range here, you will know that that is grouped data. All right. So if we look at this question now, if you notice here, this is not talking about population variance, it's talking about the sample variance. And this will always be mentioned when you're talking about standard deviation and variance. All right. So here it is talking about sample variance. The equation for sample variance is slightly different. Okay. It is not that much different. It's very slightly different. Again, the solving is going to be almost exactly the same when it comes to the solving method. Only difference is, so our sigma squared, which is our variance, the general equation of this is going to be x minus x bar squared all over n minus 1. Again, just a reminder, this is just average, all right? Usually they use x bar when you're talking about sample, and they're using mu, like I mentioned here, when they are talking about a population, all right? This is the only difference. But it's the same exact calculation, exact same way to get. Over n minus 1. All right, if you notice here now, we have n minus 1 in the denominator. I'm not sure if they're giving you any formula sheets or not. If not, make sure you guys know the differences between each, what the sample variance means and what the standard deviation, what the population variance means and all of that. All right. Anyways, this is the general form. The simplified form is going to be, which I recommend using, is you're going to have sigma. You're going to have actually n first, then sigma. You're going to have n sigma x squared minus sigma x all squared. All right, over n into n minus 1. Okay, this is the more simplified version of this formula. All right, again, we're just talking about variance. When we want to find standard deviation, we just find the square root, very straightforward. All right. So if we want to apply this equation, first let's look at our data set. So we have 3, 5. Actually, let me write it in vertically from now. Let's make it as a table. So our x value is 3, 5, 2, 6, 4, 7, 1, 8. All right. So this is my X value. Again, like I said, the solving is going to be exactly the same. So you're going to draw this table down here. All right. And you're going to add a column to it. This is going to be our sigma X down here. And this is going to be our X squared. So if we square these values, this is 9, 25, 4, 36, 16, 49, 1 squared is 1, and then 64. And then we're going to find the summation of the X squared values. So let's do it for X first. So 3 plus 5 plus 2 plus 6 plus 4 plus 7 plus 1 plus 8. That is equal to 36. In this case, it's 9 plus 25 plus 4 plus 36 plus 16 plus 49 plus 1 plus 64. That is 204. And now we are just going to, excuse me, now we're just going to apply this equation. Again, we can find our n values. This is 1, 2, 3, 4, 5, 6, 7, and 8. So we have a total of 8 values. So our n is equal to 8. Or in this case, they usually use small n when it comes to sample. All right. So our n is equal to 8. This is the formula that we are going to be applying. All right. Let me make this a little bit smaller. Okay. So this is the formula that we're going to be applying, which is our standard, our variance equation. So if we write down now, if we plug in the values, sigma squared, يساوي n, our n is 8, times sigma x squared, which is 204. All right, this is 204, which is our sigma x squared, which is, actually, let me use a different color, not green. This is sigma x squared, which is 204, which we found from here. All right, minus this sigma x all squared, sigma x being 36. Again, this value is sigma x, which we found over here. All right, divided by n, which is 8 into 8 minus 1. Again, this is just our n values. All right, they're all the same n, which we found from just counting the numbers. All right, putting this into the calculator will give us, so 8 times 204 minus 36 all squared divided by 8 into 8 minus 1. I got a value of 6. Okay, so the value here I got for this was simply just 6. That was our variance. What about our standard deviation? Standard deviation is equal to the square root of sigma squared, which is equal to square root of 6. So standard deviation is going to be square root of 6, which is also 2.45, and that is our standard deviation. And that's how you would solve it for raw data. So again, if you have sample variance, you're going to be using this equation. If you have population variance, you're going to be using this equation. And the method of application is exactly the same. The only difference is the plugging in the equations are going to be different. All right. Clear so far for raw data. Can I move on to the next set of data? Is that fine? All right. This is all. This is all what you might call it. Adi. It's the same thing. So the second part, the second type of data was single value, right? Single value data. And remember, I told you single value and grouped, it's the exact same equation. The only difference is the grouped, you're going to be using the midpoint instead of the actual value for x, because you don't have an actual value for x, right? That's the only difference. So for a single value, okay, again, we're going to have two cases. We're going to have population, and we're going to have sample. So if it's talking about population variance, all right, we are going to be using, there are two equations for this. There's the general one and the simplified one. So the general one here is sigma squared is equal to, we're talking about population, so it is sigma f times x minus mu squared over sigma f. If you notice, it is very similar to raw data. The only difference is we're going to be multiplying by the frequency, and we are going to have the sigma frequency, which is also our n. All right, so this is also equal to n sometimes. Okay, so it's the same thing. And the simplified version of this, all right, again, we are just talking about for population at the moment. All right, the variance is going to be sigma fx squared over sigma f, all right, minus all squared here, sigma f times x over sigma f. Remember again, this sigma f, sigma f, sigma f, this is also known as n, all right? The total number of everything, which is the summation of our frequency. So this is in the case of the population variance. What about the sample variance? Sample variance, you're going to have, again, the generic equation, which is sigma squared is equal to sigma f into x minus x bar of x bar squared. Again, remember, this is just average, but when used for a sample. And the difference is going to be in the denominator. You're going to be subtracting 1. If you notice, the same exact equation for population and variance and sample. The only difference is in the sample, you are going to be subtracting the value 1 from the frequency. All right? And the simplified version of this, here, this is going to be a bit more different. So you're going to have sigma f times sigma fx squared minus sigma fx all squared divided by sigma f into sigma f minus 1, right? I know this might look more complicated, but if you notice again, all these sigma f's, these are just simply n, all right? This is what sigma f is, okay? The ones that are outside. So sigma f is simply equal to n. So if you want to even further simplify it and you will understand it better, this is going to be sigma fx squared over n minus sigma fx over n squared, all right? Same thing for the sample variance. Sigma squared is going to be equal to n times, actually here they usually use small n, all right, times sigma fx squared minus sigma fx all squared divided by n into n minus 1. All right, this is the only difference that you have. I just put n instead. Now it looks a bit more cleaner. Again, remember sigma f is the same as n. All right, so this n is also sigma f. So sigma f here is equal to small n for the case of the sample variance. But remember, this is just the total number, and you're just going to add up all the frequencies to get your n value. All right. So let's look at an example over here. So let's say these are the values that have been given. All right, we have these values that have been given. To use your simplified equation, all right, we're gonna obviously have to increase the size of this table, and we're gonna have to add a few more columns. All right, I'm going to solve it using the simplified. I prefer the simplified as you will have much easier numbers to calculate in general. So remember that this is our x value and this is our f value. This is our data and this is our frequency. The first thing that you need to find is your x times f. All right. This is the first value that you need to find, which in this case is going to be 88 times 6, which is going to be equal to a number. The next one is 92 times 3. The next one is 97 times 4. And so on and so forth. All right. 89 times 2 and 85 times 5. Oh, one note. All right. It was given in the question. This is for population variance. All right. This will always be mentioned in the question, whether it's population or sample variance. So we're going to be using the population variance equations. All right. So I'm just going to keep this a bit smaller. I'm going to keep it up here. Population variance. All right. So we're going to have to calculate all these values. So it's going to be 528, 276, 388, 178, and 425. So this will be your first value, first column that you will add. The second column you will add is x squared. All right. X squared is very simple, very easy. You just square the value that you have. For example, for the first one, it's going to be 88 squared. Remember, x squared, not f squared. So this is going to be 7744. The next value is going to be, let me actually make some lines so it's a bit neater. So again, you're going to do for the next value, which is 92 squared, which is going to be 8464. The next value here is going to be 97 squared, which is 9409. And the last value, or the last two values, 89 squared is 7921. And 85 squared is 7225. So you find your x squared values now. The last step is you're going to multiply your f times x squared. So basically, the value of this, you're going to be multiplying this number with this number. All right, this is how you're going to get your value over here. So it's going to be 6 times 7744, which is going to be a huge number, 46464. The same thing you're going to apply for the rest. So you're going to be multiplying 3 by the squared value. So it is 25392, 37636, 15842, and the last value is 36125. All right. Now you're going to need to find your sums. So remember, you're going to have to find the sum of the values that you need. And the sums that you're going to have to find here. Second, all right. So the sums that you're going to need to find here, remember, this is our n, which is equal to sigma fx. Now sigma f only, just sigma f, which is just summing all these values, which is going to be 20. Okay. All right. So that is the first sum you're going to find. Then you're going to sum the next one, which is here, which is x times f. So you're going to add up all these numbers, which is 528 plus 276 plus 388 plus 178 plus 425, which is 1795. All right. And then you don't need your x squared values anymore to be summed. You need your sigma f x squared. These values over here. All right. So I'm just going to write this as f times x. Actually, no, keep it as x times f over there. But just know that this is the same as writing sigma fx, all right? Because we are using sigma fx in the equation. So again, you're just going to sum up all these values. So it is going to be 161459. And now we are just going to plug in to our equation, okay? How are we going to do that? Remember, we are talking about population variance in this question. So for population variance, second. All right. I just want there to be no confusion. So this is population variance. We're going to use this equation to find our variance, which is equal to sigma fx squared. We found that, which is 161459, divided by our n value, which is 20, minus sigma fx, which is 1795, divided by our n value, which is 20 squared. So again, we got this value, 1795, from here. This is our sigma fx, which is 1795, which is this. And our sigma fx squared, we got it from here. This is our sigma fx squared, which is this value over here. And these two are just our n value, which is sigma f. And then we can just simply find our sigma squared, which is going to be equal to 17.89. All right. If we want to find our standard deviation, which is equal to sigma, it is just simply going to be the square root of sigma squared, which is the square root of 17.89. So our standard deviation is equal to square root that number, and we'll get 4.23. Okay. This is how you would solve it for population variance. For sample variance, you will do the exact same thing. The only difference is you're going to be using this equation. So the application is the exact same way. If you notice, we have sigma fx squared here, and then sigma fx all squared here, which is the same values that we found. It's the same exact thing. The only difference is at the equation at the bottom, you're going to have n into n minus 1, and you're going to have an n over here. All right. So it depends on the question, but the application is exactly the same. Let's solve one last question, or the last case, which is grouped data or class intervals. Right? Basically, when you have a range. Right? When you have a range or an interval. All right? Again, the equations, like I said here, are exactly the same as the equations that I have already written down over here. All right? The exact same equations, nothing is different. The only difference is the value of x is going to be not talking about data anymore. All right? So now, the only difference here is our x value. This is midpoint. All right? So the difference here is our x is equal to the midpoint value. Okay? This is the only difference, but the application is going to be the exact same application as you will see now. You're going to be solving it by finding your same here for the population, sigma fx squared and sigma fx, and then your n, and the same thing again here for your sample variance instead of population. So let us look at an example of this. Let's try to solve one that has a sample variance. Let's do this one. Oops, copy this. So this is the question. The data below refers to the daily salaries of employees. So we are given this. First step, they want us to complete this table. Let us do that. And then the second step is find the sample variance. So make sure you read the question and know which type of variance. We are talking about sample variance. And then, so let us first fill out this table. All right. Let's fill out this table and let's make it larger from now, as we are going to be using it to solve as well. All right. So as you can see, our range is from 10 to 15 here. Remember, when you have 15 to 20 in the next one, this means the same as 10 less than x, less than equal to x, less than 15. All right. So make sure that you're not including the value of 15 within this range. Same thing at the bottom one. Since there's a 15 here, it will be included, but x will be less than that value at 20, and so on and so forth. All right, just keep this in mind. This is what is meant by these values. I'll just keep this up here. All right, so let us start any number that is between 10 and 15 but less than 15. So 14, that is our first one. 16 is larger. 29, 17, 11, 13, and that's it. So we have 3. This is our frequency. 15 to 20, including 15, but not including 20. So 15 to 20, 16 is 1, 17 is 2, 19 is 3, 19 is 4. So we have 1, 2, 3, 4. 4 values. All right. Again, 20 to 25, including 20, but not including 25. So 1, 2, 3, not including 25, so not that one. 3. So we have 3 values. And lastly, all the values including 25 and above up to 30, so 27, 29, 26, 25, 27, 28, 29. Oops, I missed the 21 here. This 21 here is going to be changing this from 3 to 4. And 1, 2, 3, 4, 5, 6, 7. We have 7 here. So we have a total of 1, 2, 3, 4, 5, 6 into 3. So we have a total of, we know our n is equal to 18. All right. Just double check that your sigma f is going to also be equal to 18 before you move on, just in case you might have forgotten a value. This is a nice way to check. 7 plus 4 plus 3, that's 14. 14 plus 4 is 18. This is also equal to 18. So it is correct. All right. So our values, we used all our values. All right. So we'll make this a bit smaller. My recommendation, since you guys are going to have the exam on the computer, use the tally way to make it easier for you guys. And you put an extra bar for tallying so you can find your frequencies if it will make it any easier. Now, the difference, the one main difference here between this and the previous question is that you are going to add an extra bar at the very beginning, an extra column, which is your midpoint value. So the first thing you're going to have to calculate is your midpoint value. All right. So I'm going to call this X, and this is my midpoint. So it is clear this is the midpoint. All right. That is going to be the first column I'm going to add. Let me just finish up this table. So it's going to look like this, this, and this. So the midpoint is, if you remember, you're going to add the limits and divide by 2. So it's going to be 10 plus 15 over 2, which is equal to, actually, in this case, you have to be a bit careful, right? In this case. Here, 15 is not, 1 second. Let me double check actually if it is important or not. Just 1 second. I think we should be fine. I think. But I believe this is how it's supposed to be. Because this range is technically from 10 to 14. This range is from 15 to 19 inclusive. This range over here is from 20 to 24. And this range over here is from 25 to 29. So we're going to have to find the midpoint of these actual values because we're looking at inclusivity. Remember that the midpoint is going to be between the actual values that are a part of the class itself. So the midpoint over here is going to be 10 to 15, 10 to 14. So it's going to be 10 plus 14 divided by 2, which is equal to 10 plus 14 over 2. That's going to be 12. The midpoint over here is going to be 15 plus 19 over 2. That is going to be 17. 20 plus 24 over 2. This is going to be 22. And then 25 plus 29 over 2, which is equal to 27. All right, so this is how you find your midpoint value. Again, the reason I did this is because this has to be inclusive. Yani the values, the range has to be inclusive of both the beginning and the end. All right, because 15 is not a part of the actual range in the beginning. Now that we have found our midpoint, we are going to apply the exact same steps that we did here. We're going to do our xf, we're going to do our x squared, and we're going to do our fx squared. All right. So here we are going to do f times x. All right. Then here we are going to do x squared. And then here we are going to do f times x squared. All right, this is exactly what we are going to do. So f times x, meaning it is 12 times 3, which is 36 for the first one. Second one is 17. Remember now, our x is our midpoint value. All right, so what I'm multiplying is this x value with the 3. Okay, so 17 times 4, which is 68. 22 times 4, which is 88, and then 27 times 7, which is 189. All right. Obviously, we're going to have one last row over here. All right. For the totals, I'm just going to make it a bit lower. We're going to have this for the final totals as well that we need to find. We have already found our n earlier, as it was 18 when we were double checking. So n is equal to 18. Now we need to find x squared. So x squared is simply the midpoint value squared. So the first one is 144, which is 12 squared, then 17 squared, which is 289, then 22 squared, which is 484, and then 27 squared, which is 729. And finally, we are going to multiply the frequency of 36, the frequency of 3 times your x squared value of 144 in the first case, and you will do the same for the remaining as well. All right, so 3 times 144 is equal to 432. The next one is 289 times 4, which is 1156. Then 4 times 484, which is 1936. Then 7 times 729. Again, this is exactly what I did earlier with the previous example. The only difference here is our x value is going to be our midpoint. That's it. And we just need to add that as an additional step. And now we're going to do our summation. So we need to sum here. We need to find our sum fx. So it's 36 plus 68 plus 88 plus 189, which is 381. And we're going to need to find the sum of fx squared, which is equal to 432 plus 1156 plus 1936 plus 5103. And this is 8627. Now that we have found all the values we want, since we are dealing with sample variance, all right, the question wanted sample variance, we're going to apply our sample variance equation over here. So we found out that our n is equal to 18 times sigma fx squared, which is 8627, minus sigma fx all squared, which is 381 all squared. And just 1 second. And 381 all squared all over n into n minus 1, which is 18 into 18 minus 1. Again, where did I get the values? So this is our fx, this is our fx, this is our fx, this is our fx squared, where in the equation it is over here. This is our fx squared. So this is our fx squared. And the last thing, which is our n, which is equal to 18. So it is 18, which is equal to our n. And that's it. We put this into the calculator. Sigma squared is going to be equal to 18 times 8627 minus 381 squared over 18 times 18 minus 1, which is going to be 33.08 or 09 as our variance, depending, again, the unit is going to be depending on what the class is talking about. So in this case, it is talking about BD. This is going to be the variance in BD. All right. And then if we want to find standard deviation, it is equal to sigma, which is simply the square root of sigma squared, or which is the variance, yani. So the square root of 33.09. So our sigma, which is our standard deviation, is the square root of this, which is 5.75. And that's it. That's pretty much it, right? So when we find the value for variance, this just indicates how much variation is occurring in our system. Yani how much the value is varying from the base value or from the average value of the entire system. All right. معناته we have a lot of variation at 33 BD. معناته there's more 33 BD more or 33 BD less usually for the data values compared to the average. And that's pretty much it for sample variance, population variance, and generally the variance and standard deviation. If you have any questions, feel free to ask.